Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the concept of a discrete distribution, specifically the Poisson distribution. Poisson distributions deal with the probability of rare events. The likelihood of two events occurring simultaneously is very low in these distributions. Some examples you might see is the number of car wrecks at a busy intersection, the number of phone calls made to an office during a set interval of time, the number of typos in a magazine articles. These all have low probabilities of occurring. The formula for this probability mass function for Poisson distributions is e to the negative mu to the k over k factorial. This is the probability that x equals k events, where k is the number of desired events we're looking at, and mu is the mean arrival rate, or the expectation. So a cumulative distribution will be used often to find the less than, greater than, or less than or equal to, or greater than or equal to scenarios, especially if k is really high. It doesn't make sense to do 0 plus 1 plus 2 plus 3 plus 4 all the way up to 5 for this formula if you want less than 5, when you can just look it up on a table. So be familiar with calculating probabilities using the PMF and a cumulative distribution table. I'll show you both examples in the example videos. Only difference here is that for equality, for cumulative distribution table, you would have to take that value minus the value before it. Again, this will be demonstrated in the example videos. Variance is equal to the mean, to mu, in this distribution. It's kind of weird, but they're the same thing. If you were to look at the distribution, it would be very much centered in the middle and not much width. Finally, you will be able to approximate binomial probabilities using Poisson techniques, provided that n is large and the probability is small. If you remember binomial distributions have mean equal to n times p. So you could take n times p to find the expectation, your mu, and then use the PMF here to calculate and approximate binomial probabilities. Again, the two conditions for that to occur is that n is large and the probability is small. All right? So that's an introduction to discrete distribution named Poisson. Make sure you check out the example videos to see how you work with this formula, the PMF, and how you can do some binomial approximations using Poisson. As always, practice, practice, practice is the best way to learn this stuff. Thanks for watching. Have a nice day.